Hello, Algebra 2. We are starting Unit 9. Unit 9, can you even call a unit? It's very tiny. It's just 2 lessons, and it is covering the idea of radians. So let's jump into it. We're looking at 9.1. So let's talk about something real quick before we focus on radians. Let's look at this circle. Let's assume that this circle has a radius of 1, okay? What is circumference of a circle? Circumference is 2 times pi times r. So when the radius is 1, the circumference is simply equal to 2 pi. So to go all the way around a circle is 2 pi. So what radians is a measurement that describes how far along the circle you are. Radians is a measurement, like degrees, that tells you how far around the circle you are. When we talk in degrees, we say that we've gone 360 degrees all the way around. When we speak in radians, we say that we've gone 2 pi around. We've gone all the way around the circle. So that means half of the circle is simply pi, because it's 2 pi all the way around. So pi is equal to 180 degrees, and 2 pi is equal to 360 degrees. And to go to 90 degrees, what is that? Well, that's only a quarter of the way. So if halfway is pi, then pi over 2, half of that, is 90 degrees. You see how I'm breaking up this circle? That is what radians is. Radians is a description of how far around the circle you are relative to the circumference. We know that circumference all the way around is 2 pi. So a quarter of the circle is half a pi. Half the circle is 1 pi. All the way around the circle, 2 pi. So that is what radians is. And there's a simple way to convert the two. There's a simple way to convert between degrees and radians. If you want to go from degrees to radians, you multiply by pi over 180. So you take your degree measure, you multiply by pi over 180, and radians spits out. Okay? And if you want to convert from radians to degrees, you multiply by 180 over pi. So you take the radian measure, you multiply by 180 over pi, and out spits radians. That's the quick and easy way to go back and forth between the two. But I also think it's nice for you to just keep this in mind, that 360 is 2 pi, 180 is pi, 90 is pi over 2. How else can we break this up, right? If pi is 180, how many times does 60 degrees, for example, fit into 180? 1, 2, 3 times. So 60 degrees is a third, right? It's a third, 1/3, 2/3, 3/3. So if this is pi to go halfway around, then 60 degrees is a third of pi. I know we're not always fans of fractions, but we need to try to develop that fandom here, that okay, if 60 degrees splits it up 3 ways, then that is a third, and 120 degrees is 2/3 pi, and 180 degrees is 3/3 pi, aka pi. I know I'm saying those fractions kind of quickly, maybe slow me down or rewatch, but we'll see what we can do here. So 330 degrees. When I see that, I know that 330 degrees fits into 180 6 times. 30 times 60 is equal to 180. So what I just discovered is that 30 degrees is a sixth. It's 1/6 of 180. In other words, 30 degrees is equal to pi over 6, because pi is equivalent to 180. They're the same idea. So if 30 degrees is a sixth of 180, well then it's also a sixth of pi. You could also break out that formula that I showed you here and multiply by pi over 180. And what you're going to realize is that when you multiply these two together, 30 goes into 180 6 times. And I get pi over 6 when I simplify my fraction. Negative 165, that doesn't roll off the tongue as easily. I can't picture that one as well. So you know what? Let's go ahead and use our formula. 30 degrees, it kind of just came quicker to me. Here, I'm struggling a little bit. So I know that 165 is divisible by 15, and I get 11. And 180 is also divisible by 15, and I get 12. So negative 165 is 11 pi over 12. Now with these decimals, that's obviously super gross. That's not a fraction that you can simplify. So we're going to go ahead and plug this completely into the calculator and see what we get. So I'll show you on my end what I'm doing. I'm going to take the 437.2 degrees and multiply it by pi over 180 to get my radian measure. So 7.63 radians is our answer there, okay? And the same idea here with this negative angle measure as well. So negative 1047.35 times pi over 180 gives me my radian measure of negative 18.28. Okay? So sometimes it's pretty simple to simplify a fraction. Other times when you're given a decimal, that's just too much work, right? We're not going to try to make a fraction out of that. Let's go back the other way. I like going back the other way, to be honest. Going back the other way to me makes more sense. So ignore the 7 for a second. What is pi over 2 again? That's 90 degrees. Because pi is the same thing as 180. So in your mind, you can just replace pi with 180, right? Just wherever you see pi, replace it with 180. So what we're saying here is that this is 90 degrees, but there's a 7 there, right? AKA 7 times 90. You see what I just did there? You see what I just did there? So my degree measure is 630 degrees. But like I said, you can just replace pi with 180. So if I break out the calculator here, 7 times 180 divided by 2 gives me the 630. Pi and 180 are equivalent. Just like 12 inches and 1 foot are equivalent. Negative 8 pi divided by 5. Again, just replace that with 180. So I know that a fifth of 180, if I break out the calculator here, is 36 degrees. So multiply 36 by negative 8, and I get negative 288. Again, let me say it nice and crystal clear here. Pi is equivalent to 180. So negative 8 times 180 divided by 5 gives me that negative 288. Now, over here, it's written as a decimal, just like I wrote these as a decimal. So there is no pi that's like staring me in the face, right? So we go back to this rule of 180 divided by pi. So I take my radian measure, and I'm going the other direction, so I use this one instead. I multiply by 180 over pi, and out spits my degree measure. I'm going to go ahead and punch that into my calculator off screen here. Negative 4.382 times 180 divided by pi, and I get negative 251.07 degrees. And you just do it again, right? Nothing too crazy here. You just do it again. 180 divided by pi, so 2.14 times 180 divided by pi, and I get 122.61. So just follow those formulas. The thing is, though, is that the formula isn't going to help you as much here. I'm using it, but I'm not just plugging it straight into a calculator. We need to be aware of how to simplify fractions, okay? Okay, so this is a table. Let me go ahead and fill this in real quick. I'll be pausing myself and I'll have it filled in just a moment. Okay, so I'm back and it's all filled in. These are the same values that we know and love. We've filled this table in a couple of times, right? Probably more than a couple, probably 3 or 4 at this point. This might be the 5th time that we've filled it in. So we know these values. We've seen them on the unit circle as well. We've seen them time and time and time and time again. And if you Google a unit circle, by the way, the one that I was even using in class, this lovely one right here that I used on the Socrative, look, the radian measures are literally in this picture. You see this? Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, right? They're all right here. So I'm gonna keep this up actually, because that's gonna be pretty useful. So I've got the equivalent radian measures side by side here. So these problems are the same problems that we've been doing, except, oh, wait a minute, now it's in radians. Okay, now it's in radians. So there is no crime in using the unit circle. There's no crime, right? Where's 3 pi over 4? There it is. What is sine of 3 pi over 4? Right there, root 2 over 2. Boom, there's my answer. The next one says cosine of 8 pi. Well, wait a minute. 8 pi is not on here. Okay? 8 pi is not on here. So what to do, right? Well, give me a moment here. How do we find a twin angle, a coterminal angle? We subtract 360, right? Well, these are in radians. So what should we do? We're not going to add or subtract 360. We're going to add or subtract 2 pi, because 2 pi is all the way around. So we can find a coterminal angle for this. We can subtract 2 pi a few times. We want to subtract it probably 3 times. And when you subtract 2 3 times, you're going to be left with 2 pi, right? You could subtract it all 4 times if we wanted. Right? If you subtract 2 pi 4 times, what are we going to be left with? 0. So 8 pi and 0 are the same. Where is 0 on our unit circle? Right here. And what is cosine of 0? 1. The answer, 1. We've got tangent of negative 2 pi over 3. Okay? So what is negative 2 pi over 3? Well, that means we're going down. Let me transition back. So where's 2 pi over 3? Right here. You see that? Here, let me break out my tool. We got 2 pi over 3 right here. Well, that means negative 2 pi over 3 is going to be right there. So what is the tangent value for what's this? Okay, my mind's in 2 different places at once. We can you see the reference angle with me? Can you see the reference angle right there that I've just now drawn? That is a 60-degree reference angle, right? 60 degrees, just like this one over here. Or it's a pi over 3 reference angle. I don't mean to keep switching back and forth, but I'm going to say 60 degrees just because it's probably what you're more used to for a second. So that's the reference angle. Remember how useful reference angles are. Reference angles are a tool to help you answer the question. So if this is a 60-degree angle here, sort of, we can look at our table and we know that tangent of 60 degrees, or pi over 3, is root 3. So the question is, for negative 2 pi over 3, we're still creating a reference angle of 60 degrees, but now because we're in quadrant 3, tangent is going to be positive. A, S, T, C. Tangent is positive in quadrant 3. So we're going to have positive root 3. Okay? 7 pi over 6. I haven't had my first question yet. I tend to forget that, right? I get so wrapped up in doing the math. Let's have our first question. Let me pull up the unit circle, and you tell me, what is cosine of 7 pi over 6? Some answers pop up on screen. You found 7 pi over 6, and you said, okay, I know that cosine is the x value. Boom. So the answer was simply negative root 3 over 2. Sine of 11 pi over 3. A little more challenging here because 11 pi over 3 is not on the unit circle. But can you find its reference angle? Can you find its coterminal angle? 11 pi over 3. Think that one through. Some answers are going to be on screen. I suppose you could just take a guess, but maybe try to think that one through. 11 pi over 3. Some answers pop up on screen. So you could do it a couple of different ways. 11 pi over 3. What I go back to is the idea of the reference angles. So 11 pi over 3 goes round and round a few times, but what reference angle would it create? Okay, so 6 pi over 3 is the same thing as 2 pi. Okay, right? 6 divided by 3 is 2. So because I know this is a little challenging with the fractions, but we've split it into thirds. So there's 11 thirds. Maybe we should think of it that way. There's 11 thirds. So here's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3. So 5/3 and 11/3 are like the same angle. And what is sine for 5/3? Negative root 3 over 2. Once again. Did I lose you? Should I say that again? Well, you have the beauty of rewinding. I plotted my 11/3 and said, wait a minute, 11/3 and 5/3 are like the same thing. Let me do the next one for you here. I won't have another question. 13 pi over 2. Okay, so 13 halves. 13 halves. You could just count it out. If that makes life easier, then fine. I know that might seem a little tedious, but 1 half, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves. So this angle went round and round and round, but we finally landed at the same spot as pi over 2, or 90 degrees. And what is tangent of 90 degrees? That's on our thing here. It says undefined. That's why I wrote the little x. You want to try again with sine of 5 pi? So pi is halfway around. So pi, 2 pi, da-da-da, da-da-da. So what is sine of 5 pi? Take a minute to look at that. Some answers pop up on screen. So 5 pi would be, it opens up 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So 5 pi is on this side, right? It was going to be one of two places. 5 pi is going to be on the left there. So what is sine of 5 pi? 0, right? Sine is the y value. So the answer was 0. Whoops. Sorry. What's happening? Why does it look smaller all of a sudden? You see it? Pausing real quick. Okay, it's being weird here, so bear with me. I don't know why, but I'm having to change scenes in order to make it pop up. So I'm in a slightly different spot as we look at my iPad, but hopefully this still runs okay here. Strange. Video's almost over there here. I'm sorry that I get excited when talking about radians here. I'm sorry we hit the 20-minute mark, but we're almost done here. So find S. So when I don't know why we're using S. We could have used theta. It doesn't really matter. Just find the angle for when tangent is 1 in quadrant 3. It all comes down to reference angles. So when is tangent equal to 1? Tangent is equal to 1 for 45 degrees, okay? Or aka pi over 4. So, and we're in quadrant 3. So what angle is that? In quadrant 3, that is angle 5 pi over 4. Yeah? Because that's our reference angle. We need a reference angle of 45 degrees. Because 45 degrees gives us an answer of 1. But we're in quadrant 3. So boom, 5 pi over 4. Okay? Let's do another one. Cosine is negative root 3 over 2, and we're in quadrant 2. So easy. I mean, literally just pull it up. Where is it equal to negative root 3 in quadrant 2? Right here at 150 degrees, aka 5 pi over 6. The unit circle tells us so much. This is not cheating. Use it. It is a wonderful tool. Sine is equal to negative root 2 over 2 in quadrant 4. The next question says. In quadrant 4, uno, dos, tres, cuatro, right here at, you guessed it there, at 7 pi over 4. And the last one asks us, oops, wrong scene, I forgot that I can't do that anymore. Sine is equal to a half. And it doesn't say what quadrant. That might be a mistake on my part. Sorry about that. Let's say both quadrants. Where is it equal to a half? Here at 5 pi over 6 and here at pi over 6. Both answers. Lovely. Right? You see how the unit circle just tells us? All you got to do is find the angle. And this time we're speaking in terms of radians instead of degrees. One more set of questions and then we're done, okay? One more set and then we're done. So when we're looking at these and we're evaluating, do we even need to bother? Plug into calculator. I don't want to waste your time here in the video, okay? It's already long enough. Plug into calculator. Make sure you're in Radian mode. Okay? Make sure you're in Radian mode. And do the same here. Same here, okay? But I will do one of these for you and then we'll call it quits here. I will do one of these for you and then we'll call it quits. We have to use the inverse trig function in order to find the angle. Please remember that. We must use the inverse trig function. So when I pull up a calculator here, I'm going to be in radian mode and I'm going to do inverse sine of 0.345. And that tells me the angle in radians. That's why the answer looks kind of strange, because that's in radians, not in degrees. Okay? That is in radians. So that is our angle measure in radians. So you pull it up here, S, the angle, equals 0.352. How about I do one more question on screen here to end it. Cosine of S is equal to 0.987. So I want you to inverse that and tell me what the decimal answer is, okay? Some answers pop up on screen. So you made sure that you were in inverse and radian, and you inverse cosigned it because it's a cosine function, 0.987, and you get 0.16. Now, if you're interested, let me show you something, right? This is in radians. If I convert these radians, check this out. If I convert these radians to degrees by multiplying by 180 over pi, I get the degree measure. So this is a 9.2 degree angle. Remember that. This is a 9.2 degree angle. Had I stayed in degree mode and inverse cosigned 0.987, because I'm in degree mode, you know what it's about to tell me? 9.2. Did you get chills? Did you have an aha moment there, right? Maybe. I don't know. But right there is 25 minutes. I appreciate your time. Have a great rest of your day.